So let's try to talk about the laws that we need to understand under set theory. Basically, the first law that is very important, or first laws that are very important under set theory, we need to understand what De Morgan's laws are. So what basically are De Morgan's laws? So under De Morgan's laws, basically, if you want to remember what is given here is you need to talk about the aspect of the complements. So when you have A union B, for example, in brackets with a complement outside, this is basically the same as what? So A will become A complement, the union becomes the intersection, then your B will become the B complement. Then the second De Morgan's law that you need to understand is it will basically be the opposite, where you have the intersection instead of the union. So this is going to become A complement union B complement. That's what we have as our interpretation there. So these two are referred to as De Morgan's laws. Okay. So there are some cases where they may ask you to prove these De Morgan's laws. So let me give you an example. Let's say, maybe for the sake of an example, we can say, let's say set A has got members, let's say maybe 1, 2, 3, and 4. That is our set A. Then we say for another set B, we have elements SA 0, 2, and 4. Maybe 2 and 4. Let's say that's what we have. So now let's say they ask you to prove a De Morgan's laws. So let me just create some space there. Then I'll start with the first one. In a case where we have intersection. So if you have intersection there in brackets, basically what we are saying is this becomes A complement union what? B complement. So now, how do you get to confirm these laws, De Morgan's laws? How do you get to confirm them? So what you're going to do when you're confirming them, basically where you have the brackets, look at what is inside the brackets. So for what you have in your brackets, you have A intersection B. Now a complement of a set means what is outside that set. So when you say A intersection B, then complement of it, it means that we are not interested in what is in the brackets, but we're interested in what is outside that set. Okay, so let's try to find first of all A intersection B. For the sake of our A intersection B, what basically we have is let's say we have in this case, if you look at A and B, what is the intersection of these two guys? What is common between the two sets? A intersection B is basically equivalent to, so we have we can clearly see that 2 and 4 are the common what? Are the common elements. So now complement of this, when you talk about its complement, what you're going to have is so this can be your first step, you indicate that. Then your second step is going to be the complement of it, which is going to be A intersection what? B, then complement of it. So this is going to be what? So assuming our inverse set is just adding the members in A and B, so it's moving from 0, 1, 2, 3 to what? To 4. So for our complement, the complement of A intersection B means that the elements not in this set, but within what? But within the inverse set. So if we exclude 2 and 4 from the inverse set, what are the members what we're going to have? So we're going to remain with 0, 1, and what? 0, 1, and 3. So that's what you have on your left hand side. So when you move to the right hand side, things change. What are you trying to say? Here we're talking about A complement. So A complement means that members outside what? So I can even put that. A complement means members not in A, but within the universal set. So if you compare these elements with what is in the universal set, you are going to see that only 0 is not part of A. So 0 is the only element in A complement because it's not part of A. All the elements that are part of A are not part of a complement. So union, then on our right hand side, what we have is what? We have the aspect of B complement. So for B complement, we're interested in the elements not in B, but within the universal set. So if you exclude 2, if you exclude 0, 2, and 4 from the universal set, this universal set, what is going to remain is what? You're going to remain with 1 and what? 1 and 3. So we have 1 and 3. Okay, let me write that better. So we have that. So what are we trying to find? We're trying to find the union of the two sets. So union means that you get to combine the two. So if you get to combine, you're going to have 0, 1 and 3. So the left and the right hand side are basically 1 and the same. And since they are 1 and the same, what can we say? We can therefore conclude to say, since the left hand side is basically equivalent to the right hand side, hence what? Hence confirmed. Okay, so you can also confirm the other De Morgan's law. You can try it out where you have A union B. Remember what we've talked about is for the intersection. So you can try out this one where you have A intersection B. Oh, yeah, where you have the union instead. So union B complement, then A complement intersection B complement. So we've talked about the De Morgan's laws. So apart from the De Morgan's laws, we also have what we call commutative law. So what are commutative laws? So commutative basically just tells us to say that a very good example is the aspect of addition. A plus B is the same as what? B plus A. So in terms of our sets, we can say that A intersection B is the same as what? Is the same as B intersection A. So this is our first commutative law. The second one is basically A union B is the same as what? B union of A. So these are the two commutative laws that are very important under set theory. Okay. So now, the aspect or the other law that is kind of related to commutative laws is basically, we call them associative laws. So on the aspect of association or associative laws are different from commutative laws because these apply to 3 different things. So in a case where you're adding A being added to B plus C is the same as adding A plus B first of all, then you add what? You add your C. So now some of you may be asking a question to say, okay, what is the difference? Is there any difference between what we have? Yes, there is a difference, but the result is the same. So when you have brackets, it means that first of all, start by adding what is in the brackets. So in a case where we are saying 1 plus 2 plus 4, then you come and say 1 plus 2 plus 4. In a case, you start with whatever you have in the brackets. So in this, on the left hand side, it's going to be 1 plus 6. On the right hand side, it's going to be 3 plus what? 4. Which is basically giving us what? The same result, 7. But the steps are different. So this is the aspect of the association or associative laws. So there are basically 2 as well, as you might guess. So where there is addition, we can put intersection, for example. So our first associative law tells us to say that A being intersected with B intersection C is the same as what? Is the same as A intersection B then being intersected with C. That's what it means. Okay. So now the other one basically is going to apply to union, which means that A union B union C is basically the same as A union of B then unionize with what? With our C. So these are the 2 associative laws that we have to understand on set theory. Okay. So associative laws are somehow the same with commutative laws, except they focus on the aspects of what you do first. Okay. So these are the associative laws, and I hope you'll be able to remember them the easy way or the smart way we've transcended. Alright, so let's try to talk about what we call distributive laws. Okay. Distributive laws is also a very, very important aspect. You need to understand what it means. So distributive, for you to understand better or for you to be able to remember, basically I'm going to talk about the issue of what we know under multiplication. So in a case where you have 2, or maybe let me just use letters to just save on time. So if you have A being multiplied by B plus C, this is basically the same as AB plus AC. Okay, so what does that mean? So A multiplied by B multiplied by C. So now what you need to understand is I can expand this by saying basically I'm multiplying A with what is in the brackets. Okay, so AB is the same as what? Is the same as A times B, right? Then AC is the same as A times what? Times C. We know that. We're able to see that. So now this distributive law or distributive laws are different from associative laws because you get to work with different signs. So the first distributive law is going to be A intersection. So instead of having intersection in the brackets, I'm going to have a union there. So I'm going to have B union C. So now it's kind of a case of multiplication. So it's like intersection is a multiplication there. So it's going to be A being multiplied by B, then the union, then again A intersection what? C. That's the first distributive law. For the second one, it's going to be where we have a union outside, then inside you have intersection. So as you might guess, in the brackets we're going to have A union B being intersected with what? A union of C. These are the two important distributive laws that you have to understand under set theory. Okay, so these are the major laws that apply under set theory.